Circular motion. While going to circular motion, in this class we're going to discuss about circular motion. So first we need to understand one important thing in circular motion. Suppose if a particle is going in a curved path, if a particle is going in a
Curved path.
curved path, what is the velocity of this particle? If someone asks you what is the velocity of the particle when this particle is at this point, suppose point A. What is the velocity? Is nothing but tangent to the curve at this point. Okay.
Yes, sir.
If we have to find out velocity, particle which is going in a curved path at a given point, at that point you draw a tangent, and the direction of the tangent is the direction of the velocity of the particle. Okay.
Yes, sir.
So now, if suppose particle is going like this, so I am assuming there is a force acting on this particle.
Okay.
Why am I assuming force acting on a particle? Now it is going in a curved path, right?
Yes, sir.
A body, according to Newton's law, a body tends to be at rest or in uniform motion unless until compelled by a force.
Yes, sir.
Uniform velocity. The uniform velocity means what? Velocity is comprising of magnitude and also velocity is comprising of direction.
Direction.
In a curved path, the direction is changing, right?
Yes, sir.
Yes, sir.
In a curved path, if direction is changing, that means velocity is changing or not? Even if magnitude is not
Yes,
changing,
sir.
Yes, sir.
we are sure that direction is changing or not?
Yes, sir.
That means velocity is changing. Is it uniform velocity?
No.
No. If it is not uniform velocity, that means there might be some force acting on it.
Yes, sir.
That's why I drew the force like
Yes, sir.
Okay.
force like this. Now, I'm assuming the force is making an angle theta with the velocity vector. Angle theta with the velocity vector. Now, here comes the show. I resolve this. I resolve this force into two components. What are they? One is
Okay.
one is perpendicular to the velocity, and one is
Parallel, in the direction of.
velocity. That's awesome. I'm calling it as F normal vector, and I'm calling this as F tangential. Let's say what I resolved. I resolved along the velocity direction, and I resolved perpendicular to the velocity direction, which is a normal component, and other is a tangential component.
Tangential component.
You see here, what is the work done by this force? You tell me. What is the work done by this normal component? Work done is nothing. First, I'll write
Under root of
power.
Fm
What? F dot velocity.
dot velocity.
I am finding out the work done by this Fn. That is Fn dot velocity. Power due to normal force. That is equal to how much?
0. Because perpendicular it is.
Perpendicular. Because this force n is perpendicular to velocity vector. Very crucial. You listen to important concept. Number of times examiners have touched this point. So now, if power is 0, dw by dt is equal to 0, rate of work done is 0. That implies here work done is 0. Work done is 0 means this here dw by dt is rate of change of kinetic energy, right?
Yes, sir.
Yes, sir.
That means work done is 0 due to this force means change in kinetic energy due to force is also 0 or not?
Yes, sir.
Yes, sir.
That means K final minus K initial is equal to how?
Equal to 0.
This implies most valuable. This implies K initial is equal to K final due to this normal force. Understood? So K initial is equal to K final. That means what
K
happens?
final.
The speed. K kinetic energy, you are sure about speed, right? Half into m
Yes,
into
sir.
Yes, sir.
V square.
well, speed. If you don't know the direction, suppose 2 meter per second in this direction, 2 meter per second in this direction. Speed may be same, but direction is velocity is different.
Yes, sir.
If I
Yes,
square it,
sir.
magnitude here it will give you confirmation about magnitude, but it will not give you confirmation about the direction.
Yes, sir.
That
Yes, sir.
means here speed is constant.
On.
Due to what? Due to F1 component. Normal component, due to normal force, there will not be any change in speed.
Yes, sir.
Yes, sir.
Carefully listen. Then what does it do, sir? What is the work of this force? Normal component. It actually will change the direction. What will it do?
It will
It will
change
change
the
the
direction.
direction.
But what does the Ft will do? Ft can be written as it is along the direction of velocity, right?
Yes, sir.
Ft is equal to what? M into dv by
dv by dt.
that is what? Along the direction of this Ft, along the direction of velocity directly. So then Ft is equal to what? dv by the magnitude of v by that is dt, rate of change of speed. Which is responsible for rate of change of speed?
Force.
Ah,
Acting tangentially.
So you carefully understand here. If force is there, there are two components to the force. One is normal component, one is tangential component. If acceleration is there, there are two components. One is normal component, one is tangential component. If acceleration vector you want to write, you can write it as an vector plus at vector. If force vector you want to write, fn vector plus ft vector. And what is the work of this an? To change.
Direction.
That's it. It will not change any magnitude of velocity because it is not in the direction of speed.
Okay.
Like,
yes, sir.
what is this work? What will it do? At will change the
Change the direction.
speed.
Okay. Speed.
Speed. Here also like that. Fn will not change any direction. The power supplied by Fn is 0. The power supplied by Ft is Ft into V. Got it?
Yes, sir.
Yes, sir.
Now, if speed is increasing or decreasing, At should be there. Pakka. In a circular motion, what is happening? Let's suppose you tied a ball to string and you are rotating it. The string will actually supply the centripetal force which is required for the bob to rotate in the circle. It will only change the direction.
Okay.
Okay. Now, if someone asks you speed, rate of change of speed and all, at that time directly you should think about what?
At is equal to dv by dt.
There is nothing related to
dv
AM.
by dt.
Whatever motion in 1D problems you'll solve, you can solve like this by using this component.
Okay.
But normal,
Yes, sir.
changing the direction, that is centripetal force and all, what will come into the picture? Is the AM.
Circular motion. Okay.
Reverse. Now, in case the theta is equal to 0 or 180, what will happen? The theta is not for velocity and force vector. Theta is 0. Theta is 0 means what? Force is in the direction of velocity.
Yes, sir.
Will there be any component perpendicular
Yes,
to velocity?
No, sir.
Then the particle will go in a straight line.
Okay. It will go exactly opposite when it is 180, sir.
No, it will not go. it is speed will decrease. Suppose particle already going in this direction, force is like the speed will decrease first, then it will go in the backward direction.
Okay.
If the particle
Yes, sir.
and also force is in the same direction, the speed will increase.
Yes, sir. Understood.
Suppose
Yes.
ball is going upwards, acceleration is downwards. So what will happen? The speed will decrease, keep on decreasing. While ball is going
Yes, sir.
downwards, gravitation is also downwards, then the speed is keeps on increasing.
Understood, sir.
Theta is equal to 180,
Yes, sir.
straight line motion. If theta is equal to 90 and acceleration is equal to constant, that given acceleration is constant, then it implies it must be
In circular motion.
and acceleration should be constant there. Okay.
Okay.
Yes, sir.
Theta not equal to 90 or 0 or 180. Theta not equal to these three things and somewhere between them, it may be circular.
Okay.
If it is circular, may be circular, may not be, or any other path.
Yes.
If it is circular, what will happen? AT will actually speed up the circular motion. Speed up the velocity of the particle or decrease the velocity of the particle, and AN will actually make it in circular motion. Okay.
Okay.
Yes, sir.
AN is nothing but their centripetal acceleration. Okay. Suppose
Yes,
Okay,
sir.
sir.
if you start your fan, initially what will happen? The speed will keep on increasing
Very interesting.
of any particle.
Okay.
That is due to tangential force, AT.
Yes,
Understood.
sir.
But because blade is there, the uppermost, suppose some particle is there, because of the blade, it is tied to the fan and it will rotate in circular motion. That is actually supplied by the blade tension. That is centripetal.
Okay. MV square by R.
That is mv square by r. So did you understand this both the things?
Yes, sir. Understood.
Okay.
Yes, sir.
Circular motion. Uniform and non-uniform circular motion will be there. What is uniform circular motion? Speed is
Speed.
constant.
Unit. Okay.
AT should be equal to speed is constant.
0.
Speed is not changing. What will actually change the speed? Tangential acceleration, right?
Yes, sir.
The AT should be equal to 0.
Yes, sir.
Okay.
Then AN definitely should not be equal to 0. If AN is not there, it will not go in circular motion only. If A compulsory should be there. Any circular motion
Okay.
without AN, there is no change in direction.
No, yes, sir. I understood. Tangent and normal both should be there for a circle.
Tangent may or may not be there. If it is there, tangential acceleration, so then non-uniform it will be. If it is not there, then it will be uniform. Okay.
Yes, sir.
Okay, sir.
Acceleration and V is what? Theta is equal to 90. Because only AN is there. The AT is equal to 0. That means only FN is there. That means the theta becomes what? 90
90.
degrees. Non-uniform means what? Here sometimes people will give this one also. Angular speed is constant.
Okay.
Angular speed is nothing but
Something I've heard in rotational mechanics.
omega is constant. For non-uniform, speed is not constant,
Speed is not constant.
not equal to 0. N should definitely be not equal to 0. This an is responsible for circular motion actually. So angle
Okay.
is 0 less than or equal to theta less than theta not equal to 90, because if theta is 90, 80 will become 0,
Okay.
isn't it?
Yes, sir.
You see, force is there, velocity is there. If it becomes 90, ft will become what? F cos 90. F cos 90 is 0, right?
Yes, sir.
Zero.
So if theta is 90,
Okay. If it is 80 is equal to 0, then it is uniform.
so at that time theta is equal to 90. Theta should not
Yes,
be
sir.
equal to 90, and it should not be equal to 0, and it should not be equal to 180. If 0 and 180, what will happen? It will go in a straight line.
Yes, sir.
Yes, sir.
Got it? This is the important concepts. Sometimes questions may be asked.
Yes, sir.
Okay.
Yes, sir.
Because I used to do this mistake. Sometimes in exams, the question is speed is given at a given 2 seconds or something is given, and you used to ask us what is the acceleration. Then what I used to do, mv square by r I used to do, v square by r I used to do, and get the answer.
Okay.
It will give only information about an. At also might be there for that question.
I understood, sir.
So I used to do this mistake in the beginning when I did not understand the
Yes, sir.
circular motion clearly.
Okay.
Now, again, whatever the concept that we have studied in 1D, suppose it is moving in circular motion, theta, if it is going in anti-clockwise direction, theta can be written as the form of f of t. If theta can be angular position theta. Then angular velocity. Angular velocity omega can be written as d theta by d.
DT.
That is nothing but f of f dash t.
Yes, sir.
Then angular acceleration alpha can be written as d2 theta by d2, that is equal to d omega by dt also we can write. Otherwise,
At double dash of t.
double dash of
Yes,
t.
sir.
There's another important thing which generally student will forget, like acceleration is equal to v dv by dx.
Yes, sir.
Like that, alpha can be written as omega d.
Omega d omega by dt. Okay,
D
d
theta.
theta.
Okay.
Yes, sir.
Yes, sir.
Again, if important another, if alpha is equal to constant, like acceleration is equal to constant, what will we write there? V is equal to, if a is equal to constant in linear motion, V is equal to u plus at, s is equal to ut plus
Yes, sir.
at square,
Half it
Half it.
square.
square is equal to u square plus
U square minus
U
u
square minus
square
2a.
square.
by 2 into t. Then like that, here also what we can do, s is equal to vt minus half at square, like that here. If alpha is constant, omega is equal to omega naught plus alpha t. So whatever we have learned in 1D, we can use, and but here alpha should be used. Omega is equal to omega naught plus alpha t. Theta displacement is equal to
Okay.
omega naught t plus half alpha t square. Omega square is equal to omega naught square plus 2 alpha theta displacement. Theta displacement is equal to omega plus omega naught by 2 into t. Theta displacement is equal to omega t minus half into alpha t square. Like that we can apply those equations and get the answers whatever we want. Okay.
Yes,
Okay,
sir.
sir.
Okay. Can you just go through, revise all these things for 2 minutes? I'll give you an interesting derivation, but keeping the points which I explain in this derivation are important for you because you have already completed your 11th and 12th. For board, it's okay. for objective questions and for examination, competitive examination questions, whatever the derivations I do, in that I will use some analogy. I'll get some results. Those are important. Okay.
Yes, sir.
So now there is a particle which is going in a circular motion. So from here, I thought this has covered an angle theta. Okay.
Yes, sir.
I will write here a radius vector. What? Radius vector. So radius vector can be written like this. Suppose this vector is there. So it can be written like this.
Yes, sir.
Component of x and y or not? This vector.
Yes, sir.
So this is nothing but what? R cos theta in magnitude wise. This is magnitude
sir.
R. So this is R cos theta I cap plus R sin theta J
J
cap.
cap.
If only I want to write R cap. R cap means what? You know this R cap means R vector by magnitude of R vector.
Magnitude of R
Yes, sir.
vector.
That is magnitude of R vector is nothing but capital R. If you divide it, what will get?
Yes, sir.
Cos
Cos theta I cap
I
plus sin theta J
cos
cap.
sin theta J cap.
That's it, sir.
Okay. Then write a tangential vector. Suppose the particle is going like this. I will, which is actually perpendicular this radius vector, tangential vector. Okay.
Okay.
So now tangential vector, if I take this to be R, now okay. Now can you write this vector, which is perpendicular to this vector? Suppose if this is theta, this will become theta.
Yes, sir.
Yes, sir.
If this is theta, then this will become how much? Now I'll take this one. So if this is theta, this is also theta. Alternate
Yes,
angle.
sir.
Are you getting this? Alternate
Yes,
angle.
sir.
This is theta, this is also theta. Alternate angles. And if this is theta and this is theta, this will become 90 minus theta because this vector is perpendicular tangential vector and this is normal vector.
Yes, sir.
Normal and tangential, the angle between them is 90 degrees. So this will
Yes,
become
sir.
what? 90 minus theta or not?
Yes, sir.
Now if I resolve this in the terms of I cap and j cap, this is one vector and this is one vector. Okay. The
Okay.
t cap
Yes, sir.
can be written as what? I am taking one unit magnitude. 1 into cos of 90 minus theta.
Cos.
I cap.
Yes, I cap or not?
Yes, sir.
Okay.
Plus 1 into sin of 90 minus theta into j cap or not?
Yes, sir.
So this vector I resolved into like this. Resultant of x cap and y j cap.
Okay.
Now this will become what? Minus sin theta I
Minus
cap.
sin theta I cap plus cos theta J cap.
Did you understand it?
Cos theta.
Yes, sir.
Why did I
Yes,
write
sir.
this t cap and r cap? T cap tangential vector. It will give you information about any tangential vector for you.
Okay.
Okay, sir.
If this something into multiplied by this one, if you get, that is nothing but tangential vector. Something into multiplied by this vector, if you get, then that is in the direction of radius vector. Okay.
Yes, sir.
That is
Yes,
why
sir.
I already introduced these both of the things and I kept in front of you to get the direction clearly.
Okay.
So now, if we take r
Okay,
vector
sir.
as r cos theta, these two are important. Then r cos theta I cap plus r sin theta j cap.
J cap.
That is
J
r vector. So then dr by dt is what? Nothing but what? Velocity.
Yes, sir.
Or if I differentiate is what? R into cos theta differentiation is how much?
Minus sin theta.
Actually minus sin theta into d
D
theta by
theta by
dt.
dt.
Got it?
Understood.
Because we are not differentiating with respect to time here. Here we want to differentiate with respect to time, but we have theta here.
Okay.
So you'll consider with respect to theta, we'll differentiate, that is sine theta, then we'll differentiate theta with respect to time. This is chain rule. You know this chain rule maybe in
Yes,
mathematics.
sir, I understood.
Varun,
Yes, sir.
did you understand this?
Yes, sir.
Then I cap plus sine theta differentiation is what? Cos theta
Cos theta
into
into
d
d
theta by
theta by,
dt into j cap.
yes, sir.
Answer will be d theta by dt common if you take r into d theta by dt can be written as omega
R cos, okay.
into
Omega.
what? Minus sine theta I cap plus cos theta j cap.
J cap.
So carefully listen here. Something we got here.
Sir.
What is this here? You see?
T
T, sir.
tangential vector.
T cap.
T cap.
That means what? Velocity is in the direction of T cap, right?
R omega.
Yes, sir.
So velocity direction is what? Tangential to that curve.
Okay.
And what is the magnitude of velocity? A vector can be written into magnitude into direction of that cap direction. Cap will give you direction. This is nothing but what? Suppose A vector can be written as A magnitude into A cap, right?
Yes, sir.
The magnitude of
Yes, sir.
velocity vector is how much here?
Okay, it is this thing.
R omega.
R omega.
You might have by hearted these formulas, right?
Yes, sir.
You understood
I
how
remember.
I got it? Velocity is in
Yes.
the tangential
Yes,
direction here, and magnitude is nothing but r omega.
Yes, sir.
Next,
Yes, sir.
next I will acceleration. I'll find out. Acceleration is equal to nothing but what? dv vector by dt. V vector is how much? R omega
R omega.
into so d by dt of V vector is nothing but d by dt of r omega into
R omega.
minus sin theta I cap
R omega.
plus cos theta j cap.
Cos theta J cap.
R I am taking outside and I am okay. First we will not consider omega is constant. We'll directly take R into the differentiation of two things here. D by dt of omega into minus sin theta I cap plus cos theta j cap. How will you solve it? Tell me.
Chain rule.
Not chain rule. UV rule. U dash V plus V dash U.
Q dash V.
Yes, sir.
Yes, sir.
R into omega if you keep it constant, what will you get? Omega if you keep constant, what will you get? Minus sin theta differentiation is what?
Minus cos theta into I cap plus minus sin theta j
Cos
cap.
theta into d theta by
Minus cos theta into d theta by dt I cap minus sin theta into d theta by dt j cap.
okay minus sin theta. Are you understanding, Varun?
Yes, sir.
Plus R into
Minus cos theta different minus sin theta into d theta by
Sin
dt
theta.
into j cap. R if you take this common. No, omega I kept constant and differentiated this one. Now I'll keep this constant and differentiate omega, okay?
plus d omega by dt into same thing.
Plus d omega by dt into what? Minus
Into
sin
minus sin theta I cap plus cos theta into j cap.
Got it. Okay. Awesome. Now you see R if you take common here. D theta by dt, can I take common or not here? In both the things.
Yes.
Yes, sir.
Then what will I get? Omega square. D theta by dt is nothing but omega square into minus. I am taking common in both the places.
Okay.
Here there is a minus. Here also there is a minus. If I take minus one common, what will I get? Cos theta I cap plus.
Sin theta j cap.
Sin theta J cap.
What is cos theta I cap plus sin theta j cap?
R cap.
T cap.
No.
T cap.
No. T cap is minus sin theta I cap plus cos theta j cap.
Is R cap no? sir.
R,
Oh, yeah, it is R cap.
R cap.
R cap. Okay, sir.
Carefully see, okay?
Okay, sir.
This is nothing but what? Can I write it as R cap?
Yes, sir.
Now plus this
Yes,
one,
sir.
plus this one. D omega dt can be written as alpha or not?
Yes, sir.
Yes, sir.
Alpha into minus sin theta I cap plus cos theta j cap can be written as? First I'll write it as minus sin theta I cap
T cap.
plus cos theta
T
j
cap.
cap. Can be written as what? T cap or not?
Yes, sir.
T cap.
I'll
Yes, sir.
simplify this. R into minus omega square into R cap
Plus alpha T cap.
T cap.
alpha into T cap or not?
Okay.
Yes, sir.
और सिंप्लीफाई किया तो माइनस आर ओमेगा स्क्वायर आर कैप प्लस आर अल्फा टी कैप और नॉट
Yes, sir.
Yes, sir.
दिस इज नथिंग बट acceleration. So acceleration can be written in the form of this is nothing but normal acceleration and this is nothing but tangential acceleration.
Tangential.
Tangential acceleration.
Tangential acceleration is in the direction of t cap. Normal acceleration is in the direction of minus r cap. Minus r cap is nothing but what? R cap is there going away from the center. Minus r cap is towards the center.
Okay, 180.
Towards the center. So centripetal acceleration is what? Towards the center.
Okay.
Okay, sir.
This r cap is also changing because t cap, r cap, why is changing? Theta will change, right?
Yes, sir.
Cos theta I cap plus sin theta j cap. So, but this is the acceleration. So, if someone asks you what is the force, if you multiply force, what will happen? Mr omega square into minus r cap. This is nothing but what?
Yes,
Centripetal force plus mr into alpha into t cap. This is nothing but tangential force.
Tangential.
So if someone asks you what is the magnitude of acceleration, that is equal to root over at square plus an square.
Yeah. Yes, sir.
Understood.
Got it?
Yes, sir.
These are the important things we need to consider.
Yes, sir.
And another formula we got here, V is equal to R omega. That also, that speed at a given point.
Yes, sir.
Take a note out of this. Here I'll discuss about what is centrifugal force also. Okay? I already taught you what is pseudo force, right?
Yes.
Yes.
You see here, if suppose there is a particle which is going in a circle.
Okay.
Suppose if someone is sitting here, it is in uniform circular motion. Let us assume as of now. So if you sit here, you are under you are in a non-inertial frame of reference or inertial frame of reference.
Non-inertial frame of
Because you're accelerating, right? So if the particle is going with velocity v here, magnitude, if any person who is sitting on this block is actually in a non-inertial frame of reference. If it is in a non-inertial frame of reference, what will happen?
Pseudo
force should be taken here with respect to particle away opposite to the direction of acceleration of frame of reference. Acceleration of frame of reference is in which direction? Towards the center.
Okay.
So our pseudo force will be in the
away from the center.
Away from the center. So what will be the magnitude of that one? mv square by r.
Okay.
Okay.
Why mv square by r? You see, that is nothing but here. This is centripetal force, right? Centripetal acceleration is what? AC in magnitude is what? R omega square in magnitude.
R omega.
So omega can be written as V by R.
Whole square.
Whole.
R into V square by R square. Answer will be V square by R.
By R. Yes, sir.
So here mv square by R or mr omega square, which is away from the center.
Okay.
So it is not a real force. It is a pseudo force which is applied when Newton's laws are not valid in non-inertial frame of reference. Got it?
Yes, sir.
Will you solve the problem here? Calculate the tension in a given string the block is going with a velocity v and the block is of mass m. What is the tension in the string here? It's an ideal string.
Okay. What is this L, sir?
So here the problems are on horizontal circular motion. It is not, it's in a horizontal plane only it is traveling, okay?
Okay.
If it is vertical, gravity also comes into picture, that's why.
Okay.
L is the length of the string, m is the mass of that block, L ideal string. Then the block is going with the velocity v and it's moving in a circular like this, okay?
Okay.
What is the tension in the string? Here you can simply solve like this. So now on this block, if you take the free body diagram, there will be tension, cut and pull it, okay? In this direction. So now the tension is actually providing the centripetal force, right? To move it in circle.
Yes, sir.
So the tension
Yes,
is
sir.
equal to mv square by L. But there's another way of solving it. If you take that block, if you go and sit on the block, okay? There will be cut and pull it and it is tension, right? And if you cut and pull it, there will be tension in this direction. Then if you're sitting on this, there should be a pseudo force, right?
Yes, sir.
Non-initial frame of reference. So that pseudo force should be in the direction opposite to the frame of reference
Yes, sir.
acceleration. So frame of reference acceleration towards the center. Then that pseudo force will be in which direction? Away from the
Right side.
center. That pseudo force is nothing but FPS, right? If a person
Yeah.
sitting on this, for a person sitting on this, net force is what? How much? Zero.
FPS is equal to T.
No,
Acha.
this is zero because for a person sitting on this, the block is at rest.
Okay.
So leftward force is equal to rightward force. That is tension should be equal to.
FPS.
That means tension is equal to. FPS is nothing but mass into acceleration of the frame of reference. That is.
Yes, sir.
Again, you will get the same answer.
Yes, sir.
Okay.
Yes, sir.
We'll solve the continuation problems in our next class. Because now I have a class and the class.
Okay.
Okay, sir.